Why are there no odd Windows process IDs? There are many ways to examine process IDs in Windows. For example, using the PowerShell command. We see the following output. All the process IDs are even numbers and, in addition, they are all multiples of 4. There are no odd process IDs on any version of Windows that is based on Windows NT. What is the reason for this?
Why are there no odd Windows process IDs? The same code that allocates kernel handles is also used to allocate process and thread IDs. Since kernel handles are a multiple of 4, so too are process and thread IDs. Why are process and thread IDs multiples of 4? On Windows NT-based operating systems, process and thread IDs happen always to be a multiple of 4. Is this just a coincidence? Yes, it's just a coincidence, and you shouldn't rely on it since it is not part of the programming contract. For example, Windows 95 process and thread IDs were not always multiples of 4. By comparison, the reason that kernel handles are always a multiple of 4 is part of the specification and will be guaranteed for the foreseeable future. Process and thread IDs are multiples of 4 as a side effect of code reuse. The same code that allocates kernel handles is also used to allocate process and thread IDs. Since kernel handles are a multiple of 4, so too are process and thread IDs. This is an implementation detail, so don't write code that relies on it. I'm just telling you to satisfy your curiosity. Source: why are process and thread IDs multiples of 4? Why are kernel handles always a multiple of 4? Not very well known is that the bottom 2 bits of kernel handles are always 0. In other words, their numeric value is always a multiple of 4. Note that this applies only to kernel handles, it does not apply to pseudo handles or to any other type of handle, user handles, D handles, multimedia handles. Kernel handles are things you can pass to the closehandle function. The availability of the bottom 2 bits is buried in the def.h header file. That at least the bottom bit of kernel handles is always 0 is implied by the getQCompletionStatus function, which indicates that you can set the bottom bit of the event handle to suppress completion port notification. In order for this to work, the bottom bit must normally be 0. This information is not useful for most application writers, which should continue to treat handles as opaque values. The people who would be interested in tagged bits are those who are implementing low-level class libraries or are wrapping kernel objects inside a larger framework. Source: why are kernel handles always a multiple of 4? Further reading. The Old New Thing, Practical Development Throughout the Evolution of Windows by Raymond Chen, Principal Software Design Engineer at Microsoft.